Vasco da Gama with advanced navigation equipment, which Vasco da Gama was not having, but the Kana was having. So this tells you how much advanced we were in the navigation system, in the mathematics around it, and in the instruments which were required for navigation. Now this slide tells you the kind of naval systems we had at that point of time. If you see in the top two ships are European ships, and all other bottom ships are Indian ships. And you can see their names. They are Gamini, Tari, Jangala, Plavini, Dharini, Begini. You see, we had such big ships which were almost 10 times larger than the ship available with Vasco da Gama. This was our power, this was our technology, this was our capability so many hundreds of years back. So now, how does all this come? See, when you want to navigate, when you want to go somewhere, you have to do the measurements. The foundation for this technology is mathematics. If you are strong in mathematics, you will do all these wonders. If you are not strong, then you cannot do all this. Why Europeans didn't have the navigation system? Because their counting system was very poor. They were counting in Roman letters. They were not having the decimal system. That is why they could not measure accurately. But in India, we had the decimal system. We could count very large numbers. Next. So now I will tell you what was the mathematics in India, because that is the most important thing for any civilization or any scientific discovery to happen. You have to be very strong in mathematics. Now you see, in mathematics we had the ascending powers of 10. It was given in Yajurvedam, in Agni Puja. You can read the Sanskrit text, but basically what it tells is, O Agni, may the bricks of Yagna 1 and 10 and 10 tens and hundreds and 10 hundreds and 1,000 and 10,000 and a myriad and 100,000 and million and 100 million and 100,000 millions and billion grant prosperity. So the idea is, we knew such large numbers and we could handle such large numbers. Next. You see, in the mathematics in India, we had invented zero, of course, but we also discovered the value of zero, the place value of zero rather, the place value of zero in a number we actually established. So you see, this is given in the Ganit Pad in the Aryabhatiya. There is a mathematics treatise, Aryabhatiya. There he talks about different numbers. You can see here, it is counting from 1 up to Vrinda, which is maybe 1 billion. We can skip this one. Now in the mathematics in India, there are a lot of things. We discovered the value of pi. We were excellent in Vedic geometry. We were doing cryptography. We were doing calculus. It was not just we were doing only, we discovered zero and then we were sleeping. We were very advanced in mathematics. I will touch upon some of the aspects of these advances in mathematics which we did. So you see, we all know this right angle triangle. You know, it is the Pythagoras theorem, that the c square equal to a square plus b square. Very a theorem which we attribute to Pythagoras. This is the shloka which establishes what the Pythagoras so-called discovered quite late. So this is the theorem. You can see here, Dirgha Chaturshyasya Akshanaya Rajjuh Parshmani Tiragyamini cha Yat Prathak Bhute Kurut Tadubhayam Karoti. If you translate that, it comes to a square plus b square equal to c square. We had established the Pythagoras theorem. It was done by Bodhayana and this was given in Yajurvedam. Another interesting thing, it was not just we stopped with this Pythagoras theorem. We could handle right angle triangles. Suppose you have to construct a square equal to 3 times the area of a given square. How to do it? Today if you ask any student who is preparing for JEE and all, he will tell you how to do it. This is how our ancestors did it. Pramanam Tiryak Dvikaranyaya Mastasya Kshanaya Rajju Stri Karani. The diagonal made between the diagonal of initial square and a length equal to its side gives an area 3 times of the initial square. These are just examples. You don't think that with this example, they just left it. This is only one sample which I am telling you over the thousands of things they might have done in those periods. Now let us say you want to construct a rectangle, or you want to construct a circle from a rectangle or from a square, but both should have the same areas. You see here, the transforming a circle into a square, this is given in Sulabha Sutra. So they have given one method. First you take any circle of diameter d, then divide this d into 15 parts, then select 13 parts of this line and add 1/3 of one part to b. This length in this example, it is 13.33 parts, form the side of a square which has an area equal to that of an above taken circle. If you do that calculation now, the area of the circle is 177 square centimeter, area of the square becomes 176.7 square centimeter. With a very, very small error, you can actually construct a square from a given circle and both have the same areas. When you read about this, you just wonder, that our ancestors were champions of mathematics. And you remember, today when we read mathematics, we have foreign scholars who have developed something. We are reading it and trying to understand it. For our ancestors, there was no foreigner who was giving them any guidance. These were all what you call as ab initio innovations. They were done on their own without anybody's guidance. They were the front runners of mathematics in the world. If you see this Brahmuspata Siddhanta, it talks about integers, arithmetic operations, algebra, geometry, trigonometry. You name the field of science or mathematics, you will have it in our ancient text. I am giving you simpler examples so that all of you can understand, or even the kids can understand. In India, we were knowing about the negative numbers. Today you think negative numbers is a child's play. Every child knows about the negative numbers. But to think or to conceptualize a negative number or to even imagine its existence from scratch, when nobody has told you before you thought about it, is marvelous. So we had the rules for addition, rules for subtraction, multiplication, division, and for all those things there were shlokas. Next one. You can go to the next one. So you see here the first line. Dhanayor dhanam ranam ranayo. Positive plus positive is positive. Negative plus negative is negative. Dhanaryorantaram. Positive plus negative is equal to difference of their magnitudes. Like this, so many formulas were given in which you could handle the negative numbers. Next one. Now, our ancestors knew that the orbit of planet was not round, but it was elliptical. So many ancient Bharatiya scriptures on astronomy like Surya Siddhanta, Aryabhatiya, Brahmasputa, Siddhantanam, etc., they define the elliptical orbit of planetary motion and illustrate the mathematics behind different stages of planetary motion much before Kepler did in 1609. Next one. The mathematics were particularly strong in the state of Kerala, and these are the some of the, I should call them the scientists of those period. Madhava, Parameshwara, Nilkantha, Jesthada. These were the scholars of mathematics in those times. The Madhava wrote one book called Tantra Sangraham. Now this book was found by one Britisher called Charles M. Wish, and he translated this book and then he published his own book based on this Tantra Sangraha, next one, in which he talks about the achievements done by Madhva in the field of calculus. Next one. Now this book talks about mean longitude of planets, true longitudes of planets, gnomic shadow, calculation of lunar eclipse, calculation of solar eclipse, relative motion of sun and moon, possible errors and corrections, and earth and moon positions. All these things are talked about and calculated in the Tantra Sangraham written by Madhva. Next. Now I'll talk about calculus. Actually, calculus is supposed to be an advanced topic of mathematics. So the Madhava gave an infinite series for calculation of pi. Now this pi is very important because it gives a relation between the circumference and the diameter of a circle. So he has given this formula or other a shloka, which if you convert into mathematical form, it becomes pi equal to 4 into 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus 1 by 9, and you can continue. The more you continue the series, the more precise value of pi you will keep getting. Now this was checked by the Britisher Charles M. Wilch, and he found that this is a accurate formula, accurate representation of pi. Such was the genius of our ancestors, and we are very proud to be their children. So now you think, the inventor of calculus, who was it? Was it Madhva or was it Newton? If you go to the next one, now this gives a comparison. The Hüller's formula for circumradius of cyclic quadrilaterals, it was given by Parameshwara much before Jean Hüller. Leibniz series for inverse tangent, it was given by Madhva. Leibniz power series was given by Nilkantha. Approximate value of pi was given by Madhva much before it was given by other people. Next slide I will skip. I think I have already taken a lot of time. Now you see, we were very strong in mathematics. But was it just only mathematics? You see, then we started playing with mathematics. And in the field of technology, there is something called encryption. You know, when everybody is using WhatsApp. So WhatsApp says that there is an end-to-end encryption on whatever we are messaging or we are talking on the WhatsApp. So only you and the receiver can see the message, nobody else can see in between. We had similar encryption technology in which there was an encryption method developed. It was called Katapayadi Sankhya. So you can write something using the Sanskrit language, use the Katapati Sankhya, and you can convert into a number. So only those people who know this encryption, Katapati Sankhya, they only will be able to decipher what is that number. So now I will tell you very interesting implementation of this encryption in one of the Shastras. So you read this one shloka in the praise of God Krishna. Gopi bhagyam dhuvrat shrangi shodadi sandig khal jivit khatav gal halara sandharaha. O Krishna, the fortune of gopis, the destroyer of the demon Madhu, protector of cattle, the one who ventured the ocean depths, destroyer of evildoers, one with a plough on the shoulder and the bearer of nectar, may you protect us. This is such a beautiful Sanskrit shloka. Now, apply the Katapati Sankhya to this shloka, and I have given the table in the Katapati Sankhya encryption. The first column, which is Katapaya, is given a numeral 1. Similarly, Kha, Tha, Fa, Ra is given number 2. Like that, you can convert each word or letter into a number. So when you convert this shloka into a number, what do you get? You see, what do you get? It is come on the screen. It is the value of pi accurate to 32 decimal points. This is what encryption we achieved, our ancestors achieved. This is the technology which they established. So they were not only genius, they were also playing with whatever they had achieved, and they were, they were enjoying life with this kind of things. Yeah, just 2 minutes. So now you see the innovation was at its peak. You see the top verse, which is written as Vandeham Devam Tam Shritam Rantaram Kalam Bhasaya Ramo Ramadhirapyago Leela Mara Yodhe Vase. You can read the translation. It is a poem in the praise of Lord Rama. If you reverse this, the top line, if you just read it reverse, Seva Yedhyo Rama Lali Goparadi Mara Morah Yasya Bhalam Karam Taram Tam Shritam Vandeham Devam. This is in the praise of Lord Krishna. You see the amazing part. If you read in the forward direction, it is the praise of God Rama. If you read in the reverse direction, it is the praise of God Krishna. This was the kind of innovation which our people were doing. Then what happened? Why did we become so poor country and so backward? See, the knowledge is liberator. If you want to control human beings, you have to destroy the knowledge. So what happened? We were attacked by the people who hated knowledge. You can see the example of destruction of Nalanda University by Bakhtiyar Khilji. Now what happened actually, I will just take 10 seconds. Imagine one fine day, all computers of the world get destroyed and all the scientists and engineers are murdered. Next day, how backward we will become as a human civilization? Imagine how backward we would have become. Similar thing happened with us few hundred years back when we were attacked by Mughals. Our all knowledge was destroyed. Our all people who had genius, they were killed. That is how we started becoming backward. But why could we didn't? So what we lacked? What did we do wrong? We lacked strong defense. Why? Because actually we were a land of plenty. We thought life is to be valued, it's to be enjoyed. You should do new things. You should do good things. You should think good for everybody. The total destruction we never thought of. We could never comprehend that we could be hated so much. So we lacked the Purva Paksha. Whenever somebody came to us, we never thought that what could be his agenda, why he is coming here, why Vasco da Gama is coming to India. We never thought about it. Why? What was the hidden purpose he was having? What is the belief system of somebody who is coming here? We never thought about it. Does he respect our culture? Does he respect us? Whoever is coming to us? Whatever he is telling, is he telling the truth? So we must have thought who is ours and who is the other. So who are we? I'll quickly conclude. We are Bharatiyas, children of a civilization thousands of years old. Our genes carry memory of thousands of years. Our ancestors were great. They were masters in mathematics, astronomy, navigation, architecture, linguistics, arts, music, dance, you name it, we had it. We survived two major onslaughts. Now is the time to rise again. So what are we doing now? So we have launched Chandrayaan 3, first time in the world. We are the only country who landed the Chandrayaan into the south lunar pole. No other country did it. In the field of defense, because I am coming from the defense background, in the field of defense, we recently launched Agni 5 with MIRV, which is a major leap in the defense. We are striving for Atmanirbhar Bharat. We are catching up with the world wherever we lacked. We are designing systems which may be better than the world. We are doing wonders in quantum computing, in material technology, in missile technology, and nuclear technology. Without a proper defense, we cannot survive the next onslaught. So we have to be very strong in defense. So then what should I do? Last slide. What should I do? We should take pride in our history. We should take pride in ourselves. And the message is we must strive for excellence in whatever field we choose. This will be our tribute to our ancestors, and this is our duty to our next generation. We are no less than anybody else. Namaskaram. Jai Bharat.
ధన్యవాదాలు అభిషేక్ గారు. ఫర్ యువర్ కంఫర్ట్, ఇన్ఫ్యాక్ట్ ఇన్ ఇంగ్లీష్ ఐ కెన్ సే ఇట్స్ ఓకే బ్యూటిఫుల్ దట్ ఈజ్ ఇన్ఫ్యాక్ట్ బికాజ్ తెలుగు చాలా మధురమైన భాషను వారు కూడా గ్రహించారు. అందువల్ల తెలుగులో మాట్లాడతాను వారి కోసం మన కోసమని. నేను ఒకసారి అమెరికా వెళ్తున్నప్పుడు ఫ్లైట్లో నాకు ఒక మ్యాథమెటిక్స్ ప్రొఫెసర్ కలిశారు. పక్కన కూర్చొని మాట్లాడుతున్నప్పుడు ఆయన మీరెవరు ఎక్కడి నుంచి వచ్చారు, ఇండియా నుంచి చూస్తున్నానంటే ఆయన ఒక మాట అన్నారు, ఓ ఇండియా, యువర్ కంట్రిబ్యూషన్ టు మ్యాథమెటిక్స్, ఇండియాస్ కంట్రిబ్యూషన్ టు మ్యాథమెటిక్స్ ఈజ్ జీరో, గ్రేట్ అన్నాడు. అంటే ఏమి జీరో అంటాడేంటి, మ్యాథమెటిక్స్ కంట్రిబ్యూట్ జీరో ఏమీ లేదంటున్నాడు ఈయన. చాలా బాధ కలిగింది నాకు. వాట్ ఆర్ యూ టాకింగ్ అన్న? ఎస్, యువర్ కంట్రిబ్యూషన్ టు ఇండియా మ్యాథమెటిక్స్, వరల్డ్ మ్యాథమెటిక్స్ ఈజ్ జీరో. రామానుజన్ ఎస్టాబ్లిష్డ్ ఇన్ హౌ మెనీ వేస్ జీరో క్యారీస్ ది వాల్యూ. జీరో యొక్క వాల్యూ ఎన్ని రకాలుగా ఉన్నాయని నిర్ధారించాడు. ఇది 1920, 87, 20, 33 సంవత్సరాలు జీవించాడు శ్రీనివాస రామాంజయ్యంగార్. ఇది ఒక మనకి ఒకసారి మనకు అణువణువు కూడా గర్వంతో పొంగేటువంటి విషయం ఇది. నిజానికి ఇది ఒకటే కాదు, మ్యాథమెటిక్స్ శకుంతల హ్యూమన్ కంప్యూటర్, ఆవిడ రాజకీయాల్లో కూడా ఒకసారి కంటెస్ట్ చేసింది ఎలక్షన్స్లో. ఆవిడ శకుంతల గారు హ్యూమన్ కంప్యూటర్ అంటే ఆవిడ ప్రపంచం అంతా గుర్తించింది. కంప్యూటర్ కన్నా ఫాస్ట్. మీరు ఏ డేటా అడగండి, ఏ మల్టిప్లికేషన్ అడగండి, ఏ డిడక్షన్ అడగండి, కంప్యూటర్ కన్నా ఫాస్ట్గా చెప్పేది ఆవిడ. ఆ శకుంతల గారి హ్యూమన్ కంప్యూటర్గా మనం ప్రపంచం గుర్తించింది. ఆవిడ కూడా భారతీయురాలు. భారతదేశం ఎంత గొప్పది అని చెప్పడానికి రామకృష్ణ మఠం వాళ్ళు ఒక పుస్తకం వేశారు, 100 కారణాలు, 100 రీజన్స్ వై ఇండియా ఈజ్ గ్రేటర్ దెన్ ఎనీ అదర్ కంట్రీ. ఎప్పుడు అవకాశం ఉంటే ఆ పుస్తకం తప్పకుండా చదవండి, మీ పిల్లల చేతి చదివించండి. మనం గర్వపడాలి మన దేశం చూసి, మన శాస్త్రజ్ఞుల యొక్క మేధస్సును చూసి. ఇప్పుడు అభిషేక్ గారు చెప్పినటువంటి ఈ అంశాలన్నీ కూడా మనకి మన్నం చేసుకోవడానికి, మన పిల్లలకి చెప్పడానికి, పిల్లలకి ప్రపంచంలో ఎక్కడో ఉందని గొప్ప మేధస్సు అక్కడ పరిగెత్తక్కర్లేదు, మన దేశంలో ఉంది, మన మేధస్సు ఇది. కాబట్టి మనం గర్వపడాలి. దాని నుంచి మనం వీ హ్యావ్ టు డిరైవ్ more inspiration to learn more, to gain more knowledge, to become more knowledgeable than anyone else on this in any other country. Thank you very much. ధన్యవాదాలు అందరికీ ఈ అవకాశం నాకు ఇచ్చినందుకు.
Thank you, sir. ధన్యవాదాలు. Both the sessions have been very enlightening and scintillating. Thanks to all the speakers and thanks to Valeshwar Garu for his wonderful analysis. And now we'll felicitate the guests. Thank you everyone. Thank you for joining this session. The next session will shortly start. Please stay on. Thank you. The next session starts in less than 10 minutes. Please stay on. Thank you.